Hello, good day, everybody. Can you hear me? Can you see my screen? Anyone?
Good day, Stace, so we can see you. Sir.
All right,
Can
thank you. All right, thank you for your response. We turned on my charger. Okay. All right, let's take a few seconds to scan your attendance, and then we will begin with our class today. Okay. Okay, I've already started recording. All right, good afternoon, everybody. How are you doing? Looks like attendance is 8, 10. Okay. I noticed that recently the attendance isn't very good, so I am a little bit concerned as well. So if you're, as usual, in every class, I will say this, just so that you not forget that if you're facing any issues, any problems throughout the course, yep, I'm here to help you. Because looking at the attendance rate, it's like maybe not everyone is doing well, but so far I'm not receiving any message or any call for help also. So I really have no idea whether or not you are doing well, right? So if you're listening to this and you're struggling, do let me know, right? Drop me a message. Okay, so we have come a long way throughout the semester, and right now, can you believe it? We are at the end of November already. Like this is the last week of November, yeah, right? 23rd, yeah, last week. We have 7 more days until December ends. Yeah, and in this course also, hopefully you've been with me from the beginning until right now. So I would like to also congratulate everyone who's still right here. And we are definitely moving on towards the end of our course right now. So we started off with chapter 1, we did some basic introduction. Chapter 2, we did some some Boolean algebra. Chapter 3, some logic gates. Chapter 4, K-map, remember K-map. And chapter 5, we introduced, what's chapter 5? Combinational logic. Yeah, chapter 6 also, combination logic. And today we are in chapter 7. All right. So chapter 7 marks the beginning of something a little bit different than the previous chapters, right? So in chapter 7, let me just show you what's this title. All right, in chapter 7, it is slightly different because in all of our previous chapter, we have been dealing with logic gates. We have been dealing with circuit that has no memory, no any form of memory, right? So in chapter 7 onwards, we are going to be dealing with some kind of memory in our circuit. So I'll elaborate more in the next slide. All right. So far, we have only considered combinational circuit. So combination circuit is everything that you have done from the beginning of the semester right until now. Okay. Combinational circuit has got no memory. So what is combination circuit? In short, if you were to put it into a very simple block diagram, combinational circuit basically is like this. So it's like a circuit, some kind of a logic gates inside here, gates, right? So you have some kind of inputs to the gates, and outcome from this is like the output. Okay, so these are so this input and output. So the output at the current time only relies on at the input at the current time. Okay, so this might be confusing to you, but don't worry, just stay with me. So in a sense that it's got no memory. Okay, let's say for example, right now, so I give this value of 0, 1 into my combinational logic gate diagram over here. Let's say the output gives you a value of 1, for example, right? So what happens at the next time? So let's say after 5 minutes, I decided to change. Okay, I don't want 0, 1. Let's say I want 1, 1 at the output. Okay, and next the output, this gate, they are going to consider the output of 1 and 1 over here, and it's going to make the output change based on the truth table. So the output might change to 0 or change to 1. Okay, for example, if you give it 1, 1, the output changes to 0. So what I would like to highlight over here is that this gates over here only considers the input at the present time, which means what you give it right now. It does not consider the input that you give it 5 seconds ago, the input that you gave the previous input. Okay, so it does not consider that. So this is what I mean by when I say over here, the output only depends on the present input. So it keeps no record of what is the previous input that you give it. Okay, so over here the first time we give it the input is 0, 1, and then we change this to 1, 1, right? So it keeps no memory of the previous input. So that's why in combinational circuits, we do not have memory. Okay, no memory. All right. So what is different with sequential circuit? So in chapter 7 onwards, we are going to talk about sequential circuit. From the name itself, you know that sequential circuit. Sequential means it comes from the word sequence. So it must have involved some kind of a sequence. So sequence means what? Sequence means there is order. Like this one go first, and then that's that, and then next one, and then next one. That is a sequence, right? So in sequential circuit, that is what's going on over here. All right. So in sequential circuit, it considers what you give it right now at the present time, and it also considers what you give to the circuit previously. Right. So the output only does not only depend at what you give it right now, but what you give it in the previous time. All right. So if you look around you, most circuit nowadays, we have some kind of memory. Okay, so you can imagine, right? If you're using a computer, and what happens if your computer doesn't remember what you give it like previously? It'll be a pretty useless computer. Say you have an assignment, like you're doing your assignment, and then all of a sudden you decided to turn off the computer, and then you want to turn back on the computer, and your assignment, everything on your computer is gone. And every time you turn on your computer, you have to do things from scratch again. So that would be a pretty useless computer to have, right? So that is how we need memory. That's why we need memory. So how do we have memory? In computer systems, the way we have memory is by using something we call sequential logic. So right now, you know that in computers, we don't only have combinational circuits like an AND gate, OR gate, and so forth that we've learned so far, but we also have another element that is known as sequential circuit. And this sequential circuit is going to form, is going to allow your computer to store memory. Okay, all right. So let's move on to the next one. All right. So sequential circuit has memory of past inputs and past outputs. All right. So over here, I've also in every slide you notice that at the footer of a slide, I sometimes put in additional videos. So these are the videos that I think will really help you guys in understanding the introduction of this topic. So I really highly encourage you guys to go and check it out on YouTube. Right. So I will also post this in the Teams chat, the thread, so that you guys can find this easier. All right. So I realized that it is no point if I spend 2 hours explaining what is a sequential circuit to you guys when there is someone that can do it better than me. So I'm not saying that the explanation over there is like better than me in trying to compare. No, I'm not doing that. But I'm trying to give you the best use of your time right now. Okay. So I don't want you guys to sit through 2 hours of me explaining and then you don't get it, you don't understand it. But I would like it to be so that you get the best explanation possible out there, and that I think gives you the best use of your time. And instead of me explaining for 2 hours, like maybe you can understand it better by listening to a 10-minute video, just like what I'm putting to you in this slide. Of course, if you don't check it out, if you want to listen to my explanation only, that is also fine. I really do hope that the way I explain things, they are understandable to you. But if you do not if you do not get what I'm trying to explain, you guys can feel free to check out these videos. Okay, I believe they're going to be of some help. All right, so do take note whenever you see this video link on in the footer. All right, so let's take a look at some example of a sequential circuit. Okay, so this is one classic example of a sequential circuit, and that is counter. So you guys know what's counter? Counter is like, your stopwatch. So you start counting from 0, and then you go to 1, and then you go to 2, and then you go to 3. So why is a counter a sequential circuit? Okay, so imagine right now, like you start your counter, like you start your stopwatch, right? So your stopwatch needs to know what is the present value. The present value is 0, and then it needs to know, okay, because current value is 0, and then I need to increase by 1. Then it goes to the number 1. Okay, and then it needs to know what is the previous value in order to advance it. So let's say right now it's at 1. Okay, and in order for the counter to go to the next value, it needs to know, oh, previously it had the value of 0, and now it had the value of 1. So it needs to go to the value of 2 right now. So for a counter to work, it needs to have a memory of what is the previous value. If the previous value is 0, and then the counter needs to display 1 right now. If the previous value is 1, the counter needs to display 2 right now. So that is why a counter, or stopwatch, if you like to put it that way, a counter is a example of a sequential circuit, because it needs to keep track of what is the past. Okay, compare that to combinational circuit. Right? Combinational circuit, you don't need to know what is the past value, because this past value data not relevant at all. All you need is the truth table, and the truth table just shows what you give it right now and what you output right now. Okay, so input and output at the present moment. But for a counter, we cannot do input and output at the present moment. So we need to also know what is the previous one. Okay, right. So that is an example of a sequential circuit. All right. So system with both combination logic and memory elements are called sequential logic system. Okay, so most of the time we would have a combination of both this combination logic and sequential logic. Okay, so a system must have these two elements for it to work well. All right, so this is called a sequential logic system. All right, so let's take a look at the counter. This was what I was explaining just now. All right, so a counter is, you can imagine this as a block of input and a block diagram over here. This is the counter, and it's got the input and the output as well. So for the counter to display what is the output over here, it needs to know what is the previous one. Okay, just like what I've explained just now. So if the previous value is 1, then it needs to display the output to be 2. If the previous value is 2, it needs to display the output to be 3 instead. So that's why this counter needs to keep track of what's the previous value. And inside here, inside the counter, so we have some kind of a memory. Okay, so how do we construct this memory actually? How do we make sure our system has got some memory? So this is where our class today will come into play. So memory is constructed using these two kinds of circuit. One is latches, and number 2 is flip-flop. So in this topic, we are going to learn those. What are latches and what are flip-flops? Right, so hopefully that is clear, giving you a little bit of context on what are we doing in this chapter. So today we are going to talk about just the latches, and in next class we're going to talk a little bit about flip-flops. Okay, let's take a look at this first one, latches. Okay, so when you hear the name latches, so the first thing that comes to my mind at least is this thing. I think you guys have also seen this. This is like the latch on your door, right? So this latches functions the same way as the latch on your door. So if you have a latch on the door, what you can do is to latch the door so that there's no one that can open or that can change, that can open or close your door. So basically the door is locked. The state of that door is locked. There's no changes. There's no changes that can happen. Okay. So this is very similar to what we have for latches in digital logic. So as I've said just now, a latch or latches is a plural form. So it's a storage element. Storage element means it can have memory. And so this is where the term latch comes by. So latch allows us to maintain a binary state as long as there is a power to the circuit. Okay, so imagine that so you have a, let's say over here, let's say you have a latch. Okay, so a latch has also got input and output. So if you get a 0, let's say this is a very simple latch, 0, and then it produces 0. Okay, so what a latch allows you to do is that it can make this output stay the same no matter what you do at the input. Okay, so imagine that right now we give value 0 to the input and the output is 0. So let's say at the we want to change this input. So we want to change, instead of 0 we give a value of 1. So a latch over here allows you to make this value stay at 0 even though you change this value to 0 or to 1 or to any other value. Okay, so that is what a latch allows you to do. It can maintain a binary state. Okay, so binary state means 0 or 1, so it can maintain that as long as there is power. Okay, if you plug out the power, then there's no way the latch can function anymore. Okay, so as long as the power, this latch will allow you to latch the output value. It will allow you to latch that binary state. That's why it's called a latch. Okay, right. So latches are actually building blocks for flip-flop. So just now we saw that in the previous slide, I show you that memory is constructed using latches and flip-flop. Actually, they are related. So if you have latch, then you can construct a flip-flop using a combination of many latches. Okay, so we'll take a look at that in a flip-flop class in our next upcoming class. So for now, just know that latch is a building block for flip-flop, and a latch allows you to maintain a state, okay, to latch a state. All right, so this was what I was explaining just now. If you have an output state, you can choose to latch this output state. So when you latch this output state, so no matter what you do at the input, the output will not change. So compare that to the logic diagram, to the combinational circuit, right? So if you have combinational circuit, okay, so you have inputs and outputs, right? So the moment you change this input, what happens? The moment you change this 0, 1, okay, let's say now you change it to 0, 0. So the moment you change it, the output instantly changes. Okay, so if you change the input, the output will definitely change. But in latches, what is different is that you can choose to not change. Okay, you can choose to change. You can choose to maintain that. So that is how latches, or that's how sequential circuit, they are slightly different than combinational circuit, as what we've done until chapter 6. Okay. So it turns out that in latch, there is also many kinds of latches. So we will be covering these two latches today. And as usual, as homework, I would like you guys to discover and learn what are those two, the other two latch. Okay, so we're going to talk about SR latch and D latch. Right, of course, in today's class, I am not going to leave you hanging right there. So what I'm trying to do in this class is trying to give you my fishing rod again, right? So I'm going to teach you how do you learn a new latch, what are the terms that they use, how do you interpret them, and everything. So I'm going to give you all the ingredients that you need for SR latch and D latch, and using these ingredients or using this technique that we will be covering in this class, you'll be able to use them to discover any other latch. So you have JK latch, you have T latch, you have any other, maybe other new kinds of latches as well, because the concept is the same. So I really do hope that don't just take what I say, but learn about the concepts instead. Because if you memorize what I'm trying to say over here, SR latch, D latch, so on and so forth, the truth table, and blah, 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 you will forget it after this. But if you learn the concept, you can take this concept and apply it to any latch, any other new materials. All right. So I really do hope you can pay attention during this class, because it will be very helpful in your quiz and assignments. All right. So let's talk about this SR latch over here. So SR latch is one of the latches. And how does this SR latch look like actually? So SR latch is not very different from the way it looks like this. So it looks kind of familiar right now, right? So in SR latch, they are also constructed with gates. So over here, we have two variations of this SR latch. On the left over here, we have a SR latch that's constructed with this NOR gate. And over here on the right, we also have this SR latch constructed with NAND gate instead. Okay, so for your information, latches are usually constructed using universal gates. Okay, so that's why you see over here there's NOR gates and NAND gates, NOR gates and NAND gates. Of course, you can always change this gate into the basic logic gates, but for simplicity, it is usually done this way. All right. So again, you see that this is one additional video that I really hope that you can check out after the class, because I think this video will explain so much more than I can ever explain in this limited time that we have in the class. So make this a learning experience, because I think that in the video also you would learn some of the concept that I might not be able to explain fully in the class. So coming back over here, these are latches, and these latches are constructed with NAND gates. They can also be constructed using a NOR gate. All right, so let's take a look at how they work. So this is the same latch, and over here I'm using the NOR variation, okay, NOR gate, NOR version of the SR latch. So an SR latch has got input and it's got output. Okay, so the input to this latches, they are labeled as R and S. Okay, R, S over here. So R stands for reset, S stands for set. So that is how it gets the name. Reset, and S stands for set. Okay, so we're going to look at how it works after this. It's related to how this set and reset thing is named. So the output of the SR latch, there are two outputs. So one is the output, we will usually label this as Q. Okay, so in logic gates, we can label this as any letter we like, but in sequential logic, I highly encourage you guys to label this following this letter, because it will be less confusing if everyone uses this same letter from now on. So usually in most textbooks and most videos, they will label this as Q. So Q is the output. And Q bar is the output inverted. Okay, output, but it's complemented or inverted. Okay, so that's why it's got a bar on top. Okay, so let's take a look at how does the truth table looks like. So from the beginning until now, we've been taking a look at truth table, right? So this is how a truth table of a SR latch looks like. So taking a look at this truth table, a truth table tells you the input and the output, right? Let's take a look at the first row over here. So let's say we give this value 0, 0 to the SR latch. So what is going to happen is that the output is put in a state that has no change. So I wrote here no change over here. So it means that if you give a value of 0 and 0 over here, what will happen to the output? The output will just stay at whatever value that it has previously. Okay, so take a moment to digest this. So if you give a value of 0, 0, and the output, the previous output, let's say the previous output has got a value of 0, 0, over here, it will not change anything with the previous output. So, okay, so when you give this to value over here, it goes into a no change state, NC. Okay, so whatever value that it has on the latch, it just stays there. Okay, let's take a look at what happens if we give a value of 0, 1. So let's say S we give a value of 0 and R we give a value of 1 over here. So if you have this combination at the input, now this circuit will give you a value of 0, 1 like this. Okay, it will give a value of 0, 1 like this. So what happens is that if we have the next row, if we give a value of 1, 0, so if we change this to like this, 1, 0, oh sorry, previously it was okay, maybe I just confused myself over here. So 0, 1, right? So 0 is 1, okay, 0, 1, it gives you the output of 0 like that. So what if we flip this? So if we flip this to, let's say, 1 over here and 0 over here, So what happens at the output is that the output will make this a 1 and it will make this a 0. So the output will be like this, 1 and 0. Okay. All right. So what I'm trying to highlight over here is that if you give a value of 1 at this R, input R, it will want to make this Q to be 0. Okay. So whenever we have 1 over here, this Q will be 0. And whenever we have 1 over here and 0 here, this Q will be 1. And of course, Q bar is just the opposite. It's just the complement. All right, so what happens if we have both 1 over here? So this is where something strange happens. So on one side, you want on this side, you have, because you have a value of S to be 1, so it wants to make the value of Q to be 1. It wants to have this at the output. Okay, and on the other side, you also have a value of R to be 1, and this wants to make this value the opposite. So it's like conflicting each other. So this is the state where we have, when we have two of this to be 1 like this, this is a state that is called an indeterminate state. Okay, so indeterminate state. Why is it indeterminate? Because it conflicts one another. Okay, so it conflicts one another. So on one side, it wants to make the Q 1. On the other hand, it wants to make this Q 0. So it does not settle into a value. All right. So that is why in SR latch, this state is not allowed state. So we try to make it so that at one point of time, this does not happen. Because this happen, it gives you an error in the output. So the output is, it can jump from 0 to 1 and 1 to 0 and 0 to 1 and 1 to 0. So that's why this is one of the weakness in SR latch. Okay, so let's get back to why is it called reset and set. Okay, let's just erase all this. So let's see. Point to remember over here is very simple. So if you have a value of R to be 1 over here, okay, that means it wants to reset. Okay, reset means making the Q 0. Okay, so let me write it over here. Reset. Reset means make Q to 0. Okay, this is the reset state. Reset state. Okay, makes the Q 0, and Q bar is the opposite. What about if you have a set state? If you are in a set state is this row over here. If you're in a set state, it wants to make the Q equals to 1. Okay, so how do you put your flip-flop in a set state and a reset state? So if you want to put in a reset state, you give it a 1 here, give it a 0. If you want to put it into a set state, then you give it the other way around. Put a 1 here and 0. Then you've put your SR latch into a set stage. Okay, set state. So in a set state, it wants to make this Q to be 1. Okay, so what happens if you give both 1 over here? So it's like you want to put it into a set and you want to put it into a reset at the same time. So it's indeterminate. It cannot settle at the output. So on one side, you can have a value of 1 and then you can jump to 0, 1, 0, 1, 0. So this is not an allowed state over here in SR latch. Okay, all right. So that is how SR latch works. So far, so good. Any questions so far on SR latch? Okay, let me know if you don't really understand what I'm saying, because I understand your confusion. Last semester also we had the same confusion when we arrived at this topic, because this topic is slightly different than our previous topic. So let me know if you have issues understanding so that I can explain clearly in a way that you can understand. Okay, so that is how basically how SR latch works. So if you put a value of 0, 0 over here, the output is not going to change. The output is not going to change. So whatever output that is existing is just going to stay there. And if you give a value of 1, 1, this is a illegal state. This is an indeterminate state. So SR latch should not have these two values 1 together over here, because the output will not be it'll be uncertain, the output. And the two state that we want is to either have the SR latch to be in a set state or reset state. So remember, set state is going to make it 1, and reset state is going to make the output to be 0. All right, so that is the truth table. Okay, so next, let me talk about a new kind of table also. So in sequential circuit, we also have this something we call the state table, and this state table is interesting because it's like a crystal ball. So why is it crystal ball? A crystal ball because it can tell the future. Yeah, of course, it cannot tell you your future or even my future, but it can tell the future of your SR latch or any latch for that matter. Okay, so this tells the future. It tells you what is the next output. So this next output is shown over here, and it's written like so. So Q is the output. So usually when we write Q, we mean that Q is the output at the current time. Okay, current time. So if you write Q t plus 1 like this, it means that current time plus 1, which means one time forward in the future. It can be 1 second, it can be 1 millisecond. So this plus 1 over here doesn't always mean 1 second. Okay, so it means that one step into the future. Okay, so it's 1 step to future time. Okay, so let's see what is going on over here. So we have the same thing. We have S and R. So if we have over here 0, 0. So 0, 0 means this latch is in what state? It's in a no change state. Okay, so if the SR latch, they are both in a no change state, what is the next output? The next output is going to take whatever we have at the present output. Okay, so this Qt is the output value that we have right now, and Qt plus 1 is the next one. So the next output is going to be what we have at the current output. So that's why if you have 0, 0, then you have this. So what if you have 0, 1? So 0, 1, this means that your SR latch is in a reset state. Okay, it's in a reset state. So because it's in a reset state, it wants to make the output to be 0. Okay, so what is going to happen is that it's going to make your next output to be 0. So over here, similarly, we have a set state. So we have 1 and 0 over here. So it wants to make the next output to be 1. And similarly, if we have this one, both of this one, this is a indeterminate state. So if you have indeterminate state, your next output will be indeterminate as well. So it cannot decide whether it's going to be 1 or it's going to be a 0. So that's why I put a dash over here. Okay, so that is how this SR latch works, and this is the state table. So after this, if you go online and you see the state table, then you know that the state table is supposed to tell you what is the next output. Okay. Over here, we as we have seen in the previous lecture, for any circuit, we can also have a circuit with enable. So similarly over here, we can also have a SR latch with an enable. So if you have an SR latch with an enable, this is known as a gated SR latch. Gated SR latch, and a gated SR latch looks like this. So this is a block diagram, obviously. The block diagram of a SR latch. Inside here, we have the SR latch that you see just now. However, with the gated SR latch, you have this enable as an input. So if you look into what is inside here, this is how the circuit would look like. So because you have extra E over here, then you need to have an extra gate to make sure that this E can turn this enable, can turn the gate, can turn the latch on, or it can turn the latch off. Okay, so this is how internally it looks like. It's connected in this one is the latch, as you can see over here, and this 2 is for the enable to work. So enable just tells us whether that the latch is working as usual or is not working as usual. Okay, all right. So requires an enable. The latch will not change until that enable is high. So what this means is that as long as you have the enable to be high, enable high means the latch is working well. Okay, so if you have enable high, then the latch functions as usual. If you have the enable to be low, then the latch does not function as usual. The latch just turns off. Okay, let's take a look at this truth table for a SR latch or gated SR latch over here. Okay, say for example right now, this gated SR latch is a active high enable SR latch. Okay, why is it active high? If you take a look at the circuit, it's got no bubble at the enable input. So it works. This SR latch will work when you have a value of 1, like what we have over here. Okay, so we have enable to be 1, and then this S and R, they get the value of 0, so the output will not change. Okay, the output will just remain in the present state. So you have enable 1, and then you have a reset. Okay, you have a reset because you give a value of 1 to this pin over here, to this reset pin. So because you have a 1 over here, it's in a reset state. So reset state will make your value Q to be 0. Q naught is just the opposite, 1. Okay, so the next line, we see that over here we have a value of 1, 0. So this means that this latch is in a set state. The set state means that your value of Q, it wants to make the value of Q to be 1. And finally, we also have this indeterminate state where both of this value to be 1. And this output actually, it cannot you cannot decide whether this output is 1 or 0. So sometimes maybe I'll just put a dash over here. Okay, so because there's no valid output for that. Okay, so take a look at what happens if we have this one, enable to be 0. If you put the enable to be 0, so it means that the SR latch does not work. So which means whatever value that you give to this set and reset, it doesn't change anything at the output. Okay, so that's why we put an X over here. So X stands for I don't care. So don't care meaning to say whatever value over here, you give it, it doesn't matter. It will not change anything. So that is when the enable is 0. Okay, so that is a SR latch truth table with enable input. All right, so that is all you need to know about the SR latch. So right now, before we move on to the next one, just know that right now SR latch has got 2 inputs. The S stands for set and R stands for reset. If you give a value of if you give a high value to the set, it will put it into a set state. If you give a high value to R, it will put that into a reset state. Okay, so set state means that your output will be 1. Reset state means your output will be 0. So that is the principle of how this SR latch operates. Okay. All right. So now I'm going to cover a little bit more on D latch, and then we will end our class today. So previously in SR latch, remember that there is one state, there is one weakness of the SR latch. So the weakness is that when you have S and R, they are both equals to 1. So this makes the SR latch to function in a indeterminate way. It cannot determine whether the output is 1 or the output is 0. So in order to avoid that to happen, now we have over here D latch. D latch is here to solve that problem. So what we do in D latch is we add a little NOT gate over here into the SR latch. So if you take a look at this diagram over here, inside here, this is actually a SR latch. Okay, this is actually a SR latch, and D over here is going to take the input. So D can be 1 or 0. So if D is equal to 1, then you get a value of 1 over here, but this 1 will be inverted and you get a value of 0 over here. So that's true the other way around as well. If you get 0, if you put a value of 0 over here, then 0, you get 0 here, and you get 1 here. So what this D latch solves is that it avoids the problem when both S and R, they are equal, the same. So it tries to avoid this indeterminate. It tries to avoid this situation when you have both of this equals to 1. And the way it does it is very simple. It's just putting a NOT gate to ensure that any input you give, the value of S and the value of R, they are always different. Okay, so the value of S and R, they are always different from one another. Okay, so let's take a look at the state table as well. Okay, so the state table is very simple because the input only has two possibilities over here. So it's got 0 and 1. So the D latch is very simple. D stands for data. So what this D latch is doing is that this is how I memorize it. If the value of D input is 0, the output will be 0. If the value of D is 1, the output will be 1. So it just copies the input to the output. So there is no way that we can have an indeterminate state, and there is also no way that we can have a no change state, right? Just like we see in the SR latch. So SR latch has got some flexibility, but it's got some weakness as well. And D latch is like a little bit too simple. It only has these two possibility, and it looks like it's a not very, it looks kind of dumb also, because it's like taking a 0 and then output a 0, takes 1 and output 1. But D latch can be used in many situations. It's not dumb, okay? It's not dumb latch, it's data latch, okay? So that's D latch. All right, so similarly, in D latch, we can also have a enable. So we can also have a gated D latch. So the advantage of D latch is that it eliminates the problem of SR latch, and by avoiding S and R being 1 at the same time. All right, so this is how you draw the diagram of a D latch with enable, and this is a block diagram. So if you go on Circuitverse, you would find a block diagram of a D latch that looks very similar to this, right? So you have D, and you have input and D as the input, you have enable as the input, and you have the Q as the output. Okay, all right. So let's take a look at this truth table with the enable. So if you give a truth value of 0 to enable, which means this puts your latch into a not functional state. So not functional means that you cannot, whatever you give at the value of D, it's not going to change anything. Okay, so it does not matter what you give at the value of D, right? But if you put it at a value of 1 over here, it means that your latch is going to function. So if you have a 0 over here, the output is going to be 0. You have 1 over here, the output is going to be 1. Okay, so if you give a value of 0, that puts you into a reset state. If you give a value of 1, that puts you into a, that put this latch into a set state. Okay, so that's how this D latch works. Okay, so that is SR latch, and this one is a D latch. So I figured out that before we end our class today, so this will be my last slide. So I would like to make sure that you understand this solidly before doing your research on the other two latch. So this here shows the timing diagram for a gated D latch. Okay, so D latch, simple, right? D latch is if you give it a 0, it gives you output a 0. You give it a 1, it outputs a 1. Okay, however, we also have this enable. So take a look at this diagram very, very carefully. Okay, this is going to encapsulate everything that we have said from the beginning until now. Okay, let's take a look at the first segment over here, right? So the first segment, this segment only. So in this segment, what happens is that we have a value of enable to be 0. Okay, enable 0, and then with that we give a certain input. Okay, we give value input D, and then we change it to 1. So D goes from 0 to 1, but at the same time the enable is 0. So what is going to happen at the output? So because the enable is 0, the output is not going to change. Okay, the output is not going to change. That's why the output in the beginning is 0. It stays there at 0, even though there is a change in the value of the D input. Okay, right. So that is the beginning. The first segment. Okay, so now let's take a look at this second segment over here. So second segment. In the second segment, we decided to change. Like all of a sudden, you decide to change. Okay, let's give a value of 1 at the enable. and then we keep the value of D to be 1 over here. Okay, so what happens at this time? So at this time, because the value of enable is 1 and the value of D is 1, so the value of enable is 1, it means that your D latch is working. It's now working, and then you give a value of 1. So D latch will just take the value of an input and then reflect it at the output. So that's why it's a 1 at the output, okay, because it's 1 over here. And right now, what happens is, let's say you decide to shut down this enable. Now you make it 0. Make it 0, but you don't change this. Okay, so you make this a 0, which means that you turn off your the latch. So because you turn off the latch is no longer functioning. So because of that, because your latch is now off, even though you change the value over here, because the latch is off already, it's not going to change anything. So what happens is that the value over here is latch. The value over here will not change because originally it's already a 1 over here. It's not going to change because you don't give it a enable. Okay, so now let's take a look at the next segment, or this third segment over here. And in this third segment, what happens is you give a value of 1 over here, enable to be 1. And because the enable is 1, then now the latch is functioning again. And then because the latch is functioning, it's going to see, okay, what's the value of D? The value of D is 0. Okay, it's just going to reflect here to be 0. Okay, and after some time, you turn off that. Because you turn off the latch. Now it's not going to look at the value of D anymore. Even though you change the value of D to be 1, it's not going to change anything over here. It just latches this value to be 0. Okay, so hopefully that begins to make sense to you. So let's take a look at this long segment over here as well. So now we decide to change the value, give a value of enable to be 1. So if you have a value of 1 over here, which means the latch functions, and because the latch functions is going to refer to this value. What's the value over here? The value here is 1. Now it's going to reflect over here. The value is 1. And then after that, it turns off over here, turns off, and then everything over here is off. So which means that after this point, no matter what you do, the output is not going to change. Okay, after this point, when the latch is off, okay, even though you change the output over here, up, down, up, down, up, down, like so, the output is not going to change because the latch is not functioning. It's just going to latch the same value that it has previously. Previously, you have the value of 1. It's going to latch this value and keep it the same until you have this enable again. Okay, so finally, if you have this enable all the way, so you're not going to mess around with this anymore. So if you have enable to be on, now because the latch is functioning, it's going to refer to what value here. So if 0, it's going to reflect over here. If it's 1, it's going to reflect 1 over here. And if it's 0 over here, it's going to reflect 0 here and 1. Okay, and so forth. Okay, so hopefully that makes it clear to you guys on what it means to have enable and what is the idea of the current value and the next value. All right, so I think I'm going to show you something as well. Let's see. Before we end our class, I want to show you the circuit verse. Let me show you circuit verse. If you go to circuit verse simulator, one moment, please. Circuit verse SR Latch. Let's see if I have that on circuit verse. Okay, I think I have it. me one moment to confirm this. Okay, so doesn't really work. Okay, it's okay. Okay, so that will be my last slide for today. Actually, for today, I will not give you any quiz. I figured out that you have some of you have been struggling with a lot of quizzes lately, and you guys are also cannot make it to submit. So I think considering that today there will be no quiz, but in place of that, I would like you to study on these two additional lectures. Okay, so we have a research homework, and this research homework is going to involve the other two kinds of latch, that is T latch and JK latch. So I would like you guys to go on to use the technique that I've mentioned the last time. Go onto YouTube or go onto your Google and you search this keyword T latch, and watch the first few videos. Watch the first 5 videos. Watch the first 10 videos, and from there alone, I think you would learn a lot more from those videos than I can ever explain in this class, because everyone learn things in a different way. So I am just explaining to you in one way, one method, the way that I am comfortable with. So if you guys can see how different people explain different things, like some of their explanation might suit your understanding. Okay, so we don't learn things just by one way. So that's why it's very helpful if you can watch as many as possible. Then once you watch all those 10 videos, then you will begin to draw the link between, oh, okay, what is SR latch about, how is it related to T latch. You'll begin to draw this relationship, and that is where the magic happens. Okay, so that is what I want you guys to do for your homework today. No quizzes today, so you have T latch and JK latch. Okay, so I might test you guys on these two lectures in our upcoming quiz instead. Okay, on Thursday. Okay, so if there is nothing else, then this will be the attendance for our class today. If you have any issues understanding, please feel free to stay back after the class. I will explain it in any way that might suit your understanding. Okay, all right, thank you everyone. I will see you guys on Thursday.
Thank you, sir.
Thank you, sir.